going on, YouTube? It's Boxing Day 2020. I hope you're well, and I hope you had a great holiday season. Today we're going to be installing a mini split ductless AC unit with a heat pump. You may be asking yourself, what does this have to do with woodworking? Well, actually quite a bit. In a workshop, you need a way to maintain a constant temperature, not just for your comfort and safety, but for the wood that you probably store in your workshop. You need a way to maintain a constant temperature because without it, your wood's going to expand and contract with the daily swing in temperatures, and which could ultimately lead to your wood warping, and we obviously don't want that. The reason why I'm doing this now is because I came in here a couple weeks ago and I was going to build a crosscut sled for the table saw. It's about 30 degrees in here, so I went to this wall unit. This AC unit has a heat pump as well. So I went to go turn the heat on and the motor fried. I mean, you could smell it. I mean, it's gone. It's done. So I was online searching how much it would cost to replace this. Now, this is a wall unit, much different than a window unit. It's much bigger, and this has a heat pump. These things are expensive. This is over $800. So, and another thing I don't like about this is that when it's on, I can't record in here. It's too loud. So that's why I'm opting for a mini split, because you can have it on and I can still record because it's whisper quiet. You can hardly hear it. So that's why we're going to install a mini split ductless system. Let me go ahead and show you what Santa brought me. It's 12 by 20. This is 9,000 BTUs is more than enough to heat and cool this place. This is the outside condensing unit. This is the inside unit. This is a decorative cover kit. It just covers the copper tubing, makes it look a little nicer. This is a ground rack. This is what the outside condensing unit's going to rest on top of. And this is a copper tubing kit. All told, this is about $800. The outside unit and the inside unit was about $600 and about $200 for the rest of it. So it's actually less than replacing that wall unit. So we're going to go ahead, unbox this. We're going to take a look at the tools required to get the job done. So let's get busy. The first step is connecting a power source. For me, the easiest way was to tap the existing 240 volt outlet that was supplying power to the old AC unit. Next, I drilled a hole through the outlet box, through the siding, and to the outside. I then inserted a 12 gauge wire through the flexible conduit. And then finally, I connected the wires together. Next, I affixed the conduit to the outside wall and then applied silicone sealant to the gaps in the hole. This is important to keep out unwanted guests and to keep the inside temperatures from escaping. Here I'm just connecting the wires to the cutout switch and securing it to the wall. I'm assuming no one wants to see me assemble this ground rack, so I brought it outside and I attached the condenser unit to it. Here we're connecting the 240 volts to the condenser unit. The two hot wires are connected to L1 and L2, and the ground, of course, is connected to ground. Okay, so just a couple of words regarding power. Do not do what I'm doing. I am not a licensed electrician. I'm not licensed anything. Okay, I do know how to connect these just because of my experience in the Navy. But again, I'm not licensed, so don't go by what I'm doing, okay? Okay, with that said, we were able to tap the 240 line that was feeding the old AC unit. We put a hole through the wall. We put our conduit through that hole, put the wire through the conduit. We put together that rack, that ground rack. We put the outside condenser on top of that rack, and we connected the power. So now it's time for the interior unit. Now this unit, it's not very heavy. It weighs about 25 pounds. And it came with 4 screws with anchors to go into your sheetrock, which would probably do the job just fine. I just like to find a stud. So I did take my stud finder and I found a stud here. And wouldn't you know it, 16 inches later, over on this side I found another one here. So it doesn't matter which stud I use, but the bracket's going to go up there. I'm going to level it. I'm going to mark out my spots to drill the holes for the anchors and for the studs here. And we're going to connect the inside unit. So let's get busy. Okay, now that I turned this bracket the correct way, according to the instructions, I have to drill a 2.5-inch hole so that the copper tubing and the drain pipe and the control wire get sent through the wall. So that's going to be 2.5 inches. The center point being from this point over 4 inches and up 2, which puts me right here. So we're going to go ahead and drill this hole. Now, something that's important, you don't want to drill straight through. You want to go at an angle. That way the condensation that forms, it has gravity will take that condensation out. And if it's straight, it has a chance of just staying where it's at or going back into this space, and we don't want that obviously. So you have to drill at an angle. Okay. All right, we have daylight. Okay, here's the back side of the interior unit. And what we have to do, here are your low and high supply lines. And it's copper, and what we have to do is we have to bring it out like this. And we have to be very gentle with this. The last thing you want to do is bend the copper such it puts a kink in the copper. And that's going to either put a hole in the copper or it's going to impede the refrigerant. So we want to be very careful when we bring this out. So here we go. Okay, and we're going to angle it thusly. Okay, here's the drain tube. This all goes together. Okay, so here's the control wire. They came with the copper tubing kit. So we're going to have to feed this through here, through the back, and have it come, and we're going to have to attach it underneath this access cover. So we'll go ahead and take this off now. you have terminals 1, 2, 3, and ground. And you have 4 wires in here. So, okay, this is what the terminals look like on the inside unit. I connected the control wire here. There's 4 wires, red, black, white, and green. And you have the 4 different terminals, 1, 2, 3, and the 4th one is your ground. Now, ground, I tend to always have a green wire. But the other 3, it doesn't matter what color you use to connect to the different terminals. It doesn't matter. What's important is when you connect the other end to the condensing unit, you have the same color to the same terminal. So when I connect the control wire to the condensing unit, I'm going to have the red connected to the number 1 terminal, the black connected to the number 2 terminal, and the white connected to the number 3 terminal. That's the important part, is to make sure that they match. Okay, we got the control wire connected to the interior unit. One thing I'm going to do, I have this piece of PVC that I'm going to stick through the hole. I cut it to length. It's a little ugly, but that's okay. You're not going to be able to see it. So just going to go ahead and install this. There we go. All right. Okay, again, keep your fingers crossed. But I think that did it. All right. Okay, so protruding from my workshop is the copper tubing, the drain tube, and the control wire. And what we're going to have to do now is we're going to have to bend this 90 degrees so that it's flush with the wall. And again, you have to be careful. You can't kink it. If you kink it, you got to replace the copper tubing, and that's going to be an expensive fix. So you got to be really careful and really gentle. Okay, here we go. First, we're going to take this apart. first thing we're going to do, all right, now that we have this turned 90 degrees flush with the wall here, next thing I'm going to do is I'm going to connect the control wire to the outside condenser. Okay, so now we're going to connect the copper tubing together from the interior unit to the outerior unit. I have this spool, 15 feet of copper tubing. So again, you have to be very, very gentle with this copper. It is malleable, you can bend it, and you're supposed to bend it, but you have to be gentle. Way you do this, I don't know if you can see, but these ends are flared, and it mates with this end right here, and then you tighten it. You're supposed to have a torque wrench. I don't have one. I'm going to err on the side of caution. I'm gonna tighten it, but not too extreme, not too tight. So if there is a leak, I know that I didn't tighten it enough, and I'll tighten it a little more. And this is called nylog. You're supposed to put this on the flared ends and on the outside of this nut here on the threads. Okay, the next step is to connect the copper tubing to the condenser itself. I connected a vacuum pump to the access port of the condenser and also to the blue low pressure valve. This is supposed to run for 15 minutes, and the purpose is to evacuate the system. Also, the blue side needle is supposed to read -30 or better. The vacuum pump and the valve came in a kit I got off of Amazon. I think it was $75. The next step, I closed the blue low pressure valve and turned off the vacuum pump. I had to wait another 15 minutes and check to make sure that the needle didn't move. If it did move, that means I have a leak. But in this case, everything looked good. One 1,000, two 1,000, three 1,000, four 1,000, five 1,000. Now that everything is looking good, the next step was to turn the top valve 1/4 turn for 5 seconds. This releases the refrigerant into the system. Then I had to make sure that the blue valve needle was indicating that there was indeed pressure. I also had to wait another 5 minutes just to make sure that there were no leaks. After I was certain that there were no leaks, I removed the vacuum hose from the access port. And by the way, when you do this step, you have to wear gloves because the refrigerant will leak and it could burn you. And the last step was to fully open the top and bottom valves. And that's it. Okay, a quick recap. I tapped the existing 240 line that was feeding the old AC unit and I connected that to the disconnect box out back. I also connected the power from the disconnect box to the condensing unit. We then came back inside, we hung the bracket, we drilled a hole, we connected the control wire to the inside unit, then we fed that control wire along with the copper tubing out through that hole, then we hung the unit onto the bracket. We then went back outside and we connected the control wire to the condensing unit, and then we connected the copper tubing from the interior unit to the condensing unit out back, and we filled the system with refrigerant. So now, it's the moment of truth. Let's see what happens. I heard a beep. That's usually a good sign. Let's turn this thing on. All right, I don't know if you can see it, but right there it's displaying the temperature. 62. And we have cold air coming out and you can't even hear it. It's whisper quiet, which is why I got the mini split. The old AC unit, I couldn't have it on and record at the same time. But now, it doesn't matter what the temperature is outside, I could be in here in comfort and in safety with the AC or heat on and recording. So I'm super excited. And we saved ourselves a bunch of money. It would cost well over $1,000 to have someone come in here and install this for you. On that note, I want to reiterate, do not rely on what I did in this video for your own needs. Again, I am not a licensed electrician. I do have some electronics training in the Navy, so I know my way around a couple of things. But again, I am not a licensed electrician. Do not rely on what I did in this video for your own needs. Okay, but with that said, guys, if you haven't done so already, hit that subscribe button, hit that like button, and we'll see you next time. Take care, guys.